I'll go ahead and record now.
Sir,
All
the
right.
assignment that you send is it going to be graded?
No, no. You will get it was just for yesterday, for activity yesterday, but the final thing I will put a grade on it. All right. There's more to be added on that particular assignment, but we need to go through it first. All right.
Is that the big one? Sorry, the big one I'm talking now. The one where you give with
Oh, for number
the
10,
stuff
for November
certain.
20,
What I said?
for November 20.
Yes.
Yeah, that one is graded, of course. That's our big project. So the project on Google Classroom for November 20, that is graded. All right. Very important. Please do it as soon as possible. All right. Some persons finished already. Okay, let's go.
Like myself.
Uh, okay, yes, we all know that now. All right. But ensure that ensure to get 100. All right, so we are going to investigate the factors which might affect the period of a simple pendulum. Remember we spoke about this simple pendulum? Do you remember last
Remember
week?
what?
No, sir.
No. All right. So let's go again. So a simple pendulum is an experiment that consists of a small mass hanging from an inelastic string. It is important the string is inelastic so that it doesn't stretch in the vertical direction. So it has a length L. Let's say this is 15 meters. It's not actually 15 meters, but let's just say, all right, let's say it's 1 meter. Yeah, 1 meter string, 1 meter string, right? So when the mass is displaced from its central point, this is of course our central point. When the mass is displaced from its central point, say here, that's our central point at say 15 degrees. We start at 15 degrees. You'll find out that the pendulum will go 15 degrees over this side as well. Right? It will make 15 degrees over this side. So the amount of angle over this side is the same amount of angle over this side. And when released, it will go back and forth and make oscillations. Now, it is important that we understand what an oscillation is.
Yes, sir.
You remember what
What
an
is,
oscillation is?
what is it, sir? No.
All right. So an oscillation.
An oscillation is the number of times the pendulum takes to swing from one end to another. Right?
Well, that is not oscillation, that's period. Period is the amount of time. All right. Period is the amount of time. The oscillation is the movement from the string or the pendulum from one side
To
over
one,
to the other side, and then it returns. It basically makes a cycle. We see that? It basically makes a
yes,
cycle. So it goes over here and then returns back to its original position over here. That is one oscillation. So one complete oscillation.
Sir,
Go ahead.
sir,
Question?
sir, is it possible for you to tell me the days I've missed your class?
Repeat again.
Is it possible for you to tell me the days I've missed your class?
Uh,
Like how many?
how
Not
many
actually,
days? I will
yes.
go back. I take a record. All right. I take a record, so I'll go back and
Okay.
check. All right. All right. So let's continue. Yeah. So the one oscillation is the movement of the pendulum from one side over to here. Right. We see that it goes over here and then it returns back to its original position. Right. That is considered one complete oscillation. No, the period of pendulum, as your classmate was saying a while ago, is the amount of time it takes to go from over here over to come over this side and then return back over to this original position. Right? That is one oscillation. right? One complete one period. Sorry, the amount of time it takes to go from here over to here and then return back to its original position. That is the period, the amount of time. While oscillation is the movement of the bob over here and then it returns back to its original position. Are we clear?
Yes, sir.
Yeah.
Yes, sir.
Yeah, so the period is the amount of time. All right, we can move on.
Yes, sir.
All
Move on. Continue.
right, so the factors that affect the period of a simple pendulum. So as the length of the string increases, we will find that the period of oscillation increases. Remember period? So as we increase the length of the string, say we move it to 2 meters down here. Let's put it to 2 meters, for example. We will find that the time it takes to complete the oscillation, that will also increase. And we did that in a experiment last class. All right. So if you want to look back at the experiment, you can. We did a simulation, if I remember correctly, on this. All right. Okay. So let's we said that the amplitude increases if the period of oscillation increases, right?
Yes, sir.
Yeah. So if the amplitude is our angle here, right?
Yes, sir.
Yeah. So if we move the angle from 15 to say 30 up here,
The
right?
oscillation will increase.
Yeah, the period of oscillation. Period. All right. Yeah. A period of oscillation. It will take a longer time for the bob to go from here over to here and then return back because it has more displacement to cover. It has more angular displacement to cover. It has more ground to cover. So it has to go
Here.
from all the way over here, back to its original position. It will take a longer time. And the acceleration due to gravity, as this increase, the period of oscillation decreases. No, acceleration due to gravity, you will see this coming up more often, right? It's not it's not nothing to worry about. That's very easy. Let's say we have a ball here. If we have a ball and we hold it at say 15,
Degrees.
no, let's put it at meters from the ground, right? Let's put that 2 meters from the ground, right?
Yes,
2 meters
sir.
from the ground. I will let it go. Where is the force acting? Upwards or downwards?
Upward, sir. I
If we
feel.
let it go, if we let go the ball,
Downward.
right?
Down.
So the ball will be acting downwards. Why? Why would the ball be acting
Gravitational,
downwards?
because the gravitational force, sir.
Right. So gravitational force or gravity, right?
Yes,
So the
sir.
acceleration due to gravity is dependent on the gravity, right? So acceleration due to gravity, G is dependent on gravity, right? So it's not hard. If you have a larger acceleration due to gravity, you will have a larger amount. That means that you have a larger amount of force, right? So if you go on a larger planet, you'll find that the acceleration due to gravity is different than if you go on the moon. All right, if you go on Mars, you have different acceleration due to gravity based on the size of your planet. You can do more research on this, all right, if you have the time.
Yes, sir.
Now, the final thing is that the mass of the bulb does not, I highlighted it, right? I highlighted it, the mass of the bulb does not affect the pendulum. It has no effect on it. It doesn't
What is the
change it.
bob?
So if we have a bigger mass here, we did the experiment, right? I'll repost the link in the group if you want to go back and look at it. I won't post the video, I'll just post the link, right? If we have a larger bulb here, you'll find that the period of pendulum, the time it takes to complete one oscillation will not change. All right. So
Yes, sir.
are we clear?
Crystal.
Yes, sir.
Okay. Golden is clear. Turner, you're clear. Turner just came in. Uh, are we all clear?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
All right. Good. And remember, you'll have the videos to go back through. All right. No. This is what we want to accomplish for today, right? And I want to start. I'm looking at graphs as well. So let's see how far we can go. This is some data from an experiment of one of your past students, right? One of your students was in grade 11. she lent me this data, right? She gave this data to me. This was an experiment that she did, right? So she has her she set up her apparatus, right, with with her pendulum in this way, right? And she changed the length of the pendulum. So she increased the length from here, right, going down, right? She increased the length going down. So it was originally at 42 centimeters and she increased it to 45. And then she increased this to 40 to 50 to 55 to 60. And she wanted to see how long it would take to complete one oscillation. And what is this again? The time it takes to complete one oscillation?
1.21.
No, what is the definition for this again? The time it takes to complete one oscillation. What is this again? What we call this again?
Period of
Right.
oscillation. Period.
Period of oscillation right here. Perfect. Right? No, she did this experiment and she found out that if she increased the length from 42 to 45, all right, so she did 20 oscillations. Did 20 oscillations, all right? She did 20 oscillations. I'll show you something in a few seconds. She did 20 oscillations, right? And she realized that as she increased the length, the time it takes to complete the oscillations increased. So the time to
Slow.
complete 42 at 20 oscillations at 42 centimeters, right? It increased from 24 to 26. And as she increased the length, the time also increased. So this is to complete 20, right? Complete 20 oscillations. And she increased from 50 to 55. And she saw that there was an increase from 27.8 to 27.9. And she did it again. She moved from 55 to 60. And she saw an increase from 31, from 27.93 to 31.54. All right. So are we seeing that as the length increase, the time it takes to complete 20 oscillations will increase? Are we seeing that?
Yes, sir.
All right. So Mr. Rose is seeing that. Okay, that's good. All right. Anyone have any concerns so far? You can stop me. You can send a message in the chat. All right.
Sir,
All right. I hear a concern from Miss Kitchener.
sir, in every single video you explain every single one.
I don't think I answered the question. I usually explain as best as I can.
Sir, because through me miss some of your class and when it said you see something what me never understand, so me I wonder if you explain some of them in
Yeah,
a other.
everything that I put on the test is what we did in class. All right, and it wasn't a lot, so we had to use every bit of information that we had. I see Mr. Porter saying that he's blank. Mr. Porter, I'm sorry that you were late. I will post the video on Google Classroom. We are pressed for time. All right, we don't have much time left, so I'll post the videos on Google Classroom so you can go there and then catch up back with what is happening. All right. So
Okay.
all right. So we are here. and we said that as the length increases, the time it takes to complete 20 oscillations will also increase. Now, somebody want to help me out with calculating the time for one oscillation? How do we do that again? I saw some persons doing the activity yesterday and they got it. I posted those persons in the group. Somebody want to help me to calculate the time it takes to complete one oscillation? How do we do that?
Sir, when it starts, you start the timer, sir.
All right, that is to do the entire thing, but we want to calculate the time for one oscillation. We want to do the time for one oscillation, right? Or we calculate
Sir,
that.
you divide the number of oscillations.
All
You
right, so
divide
we hear divide coming in.
the number of oscillations and time.
All right, so let's put it out there. So the period is the big T. Period is the big T, right? This is the big T right here, and the small t is the time it takes to complete 20 oscillations, right?
Yes, sir.
So what do we divide by what?
Sir, we divide the time by two.
We divide the time
By two.
by 2 or 20?
20, sir.
By 20, right. All right, is everybody clear on that? Please stop me. Please let me know. Don't sit in silent. Don't sit in the silence and don't get it. Please. I see Mr. Golden is okay. Mr. Golden understands it, right? But I need to know if um I haven't heard from
Matter
Redway,
class.
right? Perry, please just let me know if you're not understanding this or if you're good. Are you okay?
Yes, sir.
All right, that's good. I that feels so much better to hear that. All right. So as Mr. Golden rightly said, right, that the time it takes to complete one oscillation, we will have to divide the total amount of time by the time it takes to the amount that we did, which would be 20 in this case. So if you want to get the time that it takes to complete one oscillation, right, which would be our period, we have to divide the total amount of time by the number of oscillations that we did. Are we clear?
Yes, sir.
All
Yes,
right.
sir.
Yes,
Yes.
sir.
Okay. All right. That feels good to know. All right. So we found the period, and we said we see that if we increase the length from 42 to 45, there will be a change in the time it takes to complete one oscillation from 1.21 to 1.33. And the same thing, as the length increases, the period will also increase. The period will increase from 1.21 to 1.33 to 1.39. Are we seeing that it is increasing?
Yes, sir.
All right. So we're good. Are we seeing that it is increasing? Thank you, Mr. Golden. Anybody else see that it is increasing?
Yes, sir.
All right. That's good. All right. Now, how can we
Find the
calculate
period. Sir.
the period squared now? How do we do that?
Sir, you divide the time by two.
No,
How we divide?
no. Period squared.
Repeat the question, sir.
Go again.
Repeat the question.
Yeah, we
Divide it by itself. I mean, multiply it by itself.
right, multiply by itself. All right, so multiply by think itself. Thank you, Miss Kitchener. So the question was, Mr. Rose, that if we want to calculate the period squared, right? The period squared would be 1.21 times what by itself, right?
Oh,
Yeah. So period squared would be t squared. You can put it in a calculator and you can just put in 1.21 and then click squared and then your calculator would do that for you. All right, so we see the same trend as the length increases down. We see where this is also increasing. All right, are we clear now? Are we good? Any concern?
Sir,
All right, are you concerned?
sir, when you're multiplying it by itself, you're only multiplying the numbers behind the decimal point.
All the numbers. So you say 1.21 times 1.21.
So all you get back 1.31. Or you get back, yeah.
Remember that we are multiplying, we're going across. This is one set of readings for 42, right? So this is time for at 42, right? The period at 42, and this is the period squared. So this would be an answer. If you multiply 1.21 times 1.21, you should get 1.46. You see that? Try it in a calculator.
Sir, me not like do that. Me like do it myself and understand.
All right. So you can go ahead and multiply 1.21 by itself, and then you will get your answer. All right. Are we all clear now?
Yes,
Yes,
sir.
sir.
All
Yes,
right.
sir.
All right. Beautiful. Now,
Sir,
go ahead, Miss Kitchener.
sir, I got 1.331.
When you multiplied 1.21 times itself,
Yes, sir.
let me just double check that. Let me check that again.
Yes, by itself, sir.
Yeah, by itself. Multiply 1.21 by itself. So you say 1.21 times 1.21.
No, sir. Multiply
I got
1.21.
1.4641.
Yeah, 1.46. Yeah, that's what I get as well. You see that, Miss Kitchener?
A 1.21 me do.
You must multiply 1.21 times 1.21. That is 1.21 squared. It's the same thing. I see Miss Turner has a question. Miss Turner, could you elaborate, please, as your question? Could I hear your question, please? Or you can type it in the chat. All right. I guess I'll be waiting on Miss Turner until she finish types. Miss Kitchener, are you seeing that now?
Oh, yes, sir.
Okay, beautiful. All right. So we will do the same. We would have done the same thing for this one, 1.33. We multiply 1.33 times 1.33. That would be 1.33 squared. How much do we get? Oh,
1.7689.
yeah. So we just round up to 1.77, right?
Yes, sir.
Are we all seeing that? I'm not hearing from everyone else. I don't require anybody to turn on the camera, right? I would just want
Sir,
to know that you're understanding.
sir, I got 1.76.
Okay, and we rounded it up to 1.77,
Oh,
right?
oh, oh.
Yeah.
Yes.
Miss Turner, you have a question? All right, I see message again. All right, no, we're not hearing you, Miss Turner.
Your mic is open?
So I'll send a message back to her. Please, connect your internet audio. Internet audio. Probably that is the problem. All right. Okay, so let's move on. We have 3 minutes until this is closed. All right. All right. So we're going to go now into plotting graphs. So we have done the first part of finding out the factors that affect a simple pendulum. Now we're going to go to plotting graphs. All right. That's what we want to accomplish next. Right. Now we take out the important points. I see a question.
Excuse me, sir.
Yeah. Who is this?
Sean. It says that the meeting time remaining is 2 minutes. So why don't you log off and we log on back?
All right, that's a good suggestion. I will do that now. All right, so you may go ahead and
No, on the
I'll close.
cyber.
I'll close
So
and
you
then come
have
back
to
again.
wait till it. No, you have to wait till the time finish and then I can use back the same link. Come back for the
No,
meeting.
I can use like the same link as well.
Oh,
Yeah, man, I can use like the same link. All right, so we'll stop here and then we come back. All right.
Yes, sir.
Yes, sir.
Okay.